Hello everyone, welcome back again to the NPTEL online course on research methodology for planning and architectural studies. In our last lecture, we have discussed about the non-probabilistic sampling. So wherever you are going for sample collection, so there are different way that we have discussed the sampling must be done, because we cannot really take account the whole population data, because it is sometimes like very time consuming, and if the population set is too big, so it will also be very much cost incursive. So for such reason we have to go for sampling. So in our previous lectures we have seen different type of non-probabilistic sampling, where also we have discussed the limitations in such cases, that okay, there might be some sort of bias in the sampling. To overcome it, so we have another option to go for sampling, that is called probabilistic sampling. So in today's lecture, which is lecture number 23rd, we will be discussing sampling technique part 2, and in this we will be discussing the non-probabilistic sampling. So what will be our objective out of this lecture? First we will try to understand what is probabilistic sampling, then we will also discuss about the type of probabilistic sampling mostly used in the research in planning and architecture, and then also we will discuss the characteristics of probabilistic sampling and also the advantages and some of the limitations of this as well. See, this is something, the common slide that we have used in our previous lecture, that sampling can broadly be classified into two. One is non-probabilistic sampling that we discussed in our lecture 22, and now we will be focusing on the probabilistic sampling. We take the same example of 20 population, right, and then we will try to understand it. Now what is probabilistic sampling? In this case, we also refer this as random sampling. Selection of respondent is based on some random chances. It is not based on my convenience or based on my judgment that I will pick this particular sample out of population. So in these cases, it is much more on random, and there is probability. So maybe this will have a equal probability, and depending on the type of probabilistic sampling, we have certain kind of characteristics. In this case, every unit has equal probability to be respondent of the sample survey. So that's, I just mentioned that in random sampling it can be anyone, like in a group where like maybe you, me and other 5 persons are there. So the selection of the respondent is very random. We never know that who will be selected as respondent. So it is equally likely. Respondents are chosen based on certain probability, and definitely in this also it also depends on the purpose of the study. If you want to capture a particular segment of population and that you want to be repeated, so then probably you have to specify your randomness, or else you just totally go with some kind of any random number. So there are certain way to do this data collection and going for this kind of sampling. So if you say random sampling, that means we generate a random number, okay, and then we pick those kind of respondent to take part in our survey. So if you generate a random number, say 1, 3, 8, 11, 12, so there is no such kind of pattern that you will find in that random occurrence, and then the selection of any respondent is equally likely. Now coming to the classification, broadly used probabilistic sampling, we will discuss about simple random sampling, then systematic random sampling, then stratified sampling. We will also learn about the cluster sampling. So this cluster sampling, quota sampling, you will find certain similarity, but only selection of respondent is much more like random in nature. So we will start with the simple random sampling, what exactly it is. So it's the same set of example, like we have this population, total 20 persons, and then we have to select a sample size of 5. That was also the case for the non probabilistic sampling. Now in this case, if we consider the simple random sampling, it is basically based on the random number, you know generator. So you create a random number. In this case, you can also see the way it is selected, that this is 4th, then 10th, then 11, and then you have 12, 13, 14, 15, 16, 17. So you will not get any pattern out of it, no like arithmetic or geometric progression that you observe. So it is very much random in order, so that you just simply go for a simple random number generator through maybe different calculator you are having, or maybe you can use the rand common in your Excel. So if you just put rand and you can just make it open, you don't give any range, so it will create some random numbers, but only thing in this case, there will be a repetition of numbers. So there are different ways you can generate the random number and with no repetition, because the same person will not be picked up once again, because then that will have a biasness, that if you ask the same person again and again, and then you miss out other persons. So without repetition, if you generate the random number and then you just follow it, suppose you find, you are going to do a survey that we have discussed earlier, for the data collection or the sample size determination, that okay, if we want to understand the perception of metro users to the metro facilities or the service quality of metro, then how we intercept. So in this case, you just maybe stand in a particular position, you observe that this is passenger number 1. So I'll not select based on this random number. The passenger number 2, I'll approach and I select, and then if it is there, then we can allow another person to go and then approach the 4th one. Like that, you just follow it. So that means whatever random number you have generated, you are just following it to pick up the sample. So this is very important, and many a times we miss it out, because maybe we say in our research writing that okay, we have used the simple random sampling, but how you assure the randomness, and also basically this is the way that maybe you generate the number 1, 3, 8, 11, 12, 16, 18, 25, like that. So then you just don't ask the question to person, the second person, or maybe the 4th, 5th, 6th and 7th person. Like that, you can maintain that okay, whatever through my random number generator I am getting that particular randomness, because that is something very important to scientifically and statistically follow the randomness of your respondent. It is very important. Now, where we use this random sampling? So normally, wherever you have something to study at a broad level, so there is no such kind of other constraint, or other specific demands of your research, that we have to tap a specific characteristics of people. Say if I want to do a general survey and the passenger survey in the metro station, the same example I am taking, so it will help you to understand better. If my intention is to just understand their perception regardless their age, gender, income level, trip purpose, so in that case simple random sampling probably will go very fine, because we are not looking at other socio-demographic characteristics of the respondent, and any respondent is a good respondent to me, and then the response is equally important for me. But at the same time, if we have other objectives in mind, that no, I would like to know the perception of female passengers towards the metro facility or the safety in the public transport, such kind of cases, because that is some area where you want to understand their perception, and with some hypothesis that perception of male and female passengers will differ. In such cases, definitely, like say you need to tap the female passenger, or maybe you want to have a equivalent number or equal representation of your male female passenger, or maybe the young age or the old age population into consideration for your study. In such cases, maybe this simple random sampling will not work, because as per your random number generator, maybe the numbers that is generated all are male population, or all are maybe a certain age group, because it is random. You are you supposed to accept that particular respondent, okay, which is assigned this number, okay, where you count those kind of numbers and then you pick up the passenger for your survey. So in such cases, maybe the purpose of capturing a specific user group will not be fulfilled. So that is something where you should not really use for simple random sampling. Or maybe where the population is too much and there are heterogeneity already present. You know that okay, there are different side of kind of socioeconomic variation. Say for example, in a particular study area, you want to capture the socioeconomic presence, like maybe the income level. You can say that okay, low income or EWS, economically weaker section, or middle income group or high income group people. So it's a very clear definitions, and country to country there are certain kind of label set for such group of income people. Now for such cases, if you know that that heterogeneity presents in a location, you will have population which belongs to EWS, you have population belongs to LIG, or population belongs to even the higher income group. So for such cases, if you intercept with simple random sampling technique, maybe you will not capture each of the group, okay. So for that, definitely you have to think of some other sampling technique. Hope this is clear to you. With that, we move to the next one. In this case, it is again a random sampling, but this is much more systematic. So in this case, it is not the truly random number that we are going to pick up. Then we decide that we'll capture every nth individual. So this is something, some kind of rule you said, that each third person or each fifth person you are going to capture. In this case, it is the fourth person. So the number, if you say that, here you will get a pattern. So 4, 8, 12, 16 and 20. So in such cases, you get a difference of 4 in all such cases. And probably if the population is also infinite, you go like that, then this will be 24, 28, 32, like that. So you will have a logic, a sequence, and you pick up. But again, in this case, the main problem remains same. How do you know that 4th, 8, 12, 16 and 20, they are making a balance between male and female? In this case, probably if you only take this as example, like I have certain target to pick up say 5%, but out of that 3 female, 2 male, or 2 male, 3 females, like that. In all such cases, it is very difficult. Say with this particular number, what we are getting? We getting 4th one male, 8th is male, 12th is male, and then 16 is female and 20 is female. So with this setup, we are getting 3 male, 2 female. So if that is my intention, so this is solved. But the moment I change this number, okay, maybe not the 4th one, I'll go for 3rd one. So in this case, the number will change. So 3rd, then you have 6, then you have 9, okay. Then like that, if you just going in this direction, so you'll end up with something like 3rd one is female, but 6th one is male, 9th one is male, and then 12th is male, and then 12, then you have the 15th one. So 15th one is again male. So if my target was 3 male, 4 female, so in this case already we are reaching to 4 male population. So with that number also, it is not giving you any assurance that if you have a specific target to tap a particular characteristics among respondent to have a equivalent representation of the population. So then here also you can have certain kind of issue. So many a times we face the same issue, and then the common questions that we get in terms of review whenever we submit paper or for publication. So the reviewer used to say that okay, your sample is saying that okay, in your study you found 60% male, 40% female, say for example, but in your city where you have done the study, your population characteristics says it is different, where probably it is almost like 52% male and then 48% female. So why there is mismatch? So this mismatch is possible because maybe the area that I am tapping or the area that I am working on, maybe there is some kind of higher participation from male than female. Say for example, like still in Indian situation, if you say the work trip in concern, that only the person who are going for work, so then obviously in such cases we are having little higher percentage of male population than female. But this is something, again, it's I said that in general it is the observation, but that may also be something different in some of the cities if the purpose is changed. Suppose if we want to conduct some sort of study that okay, in a particular city where probably the sex ratio, where it is something like the number of female in 1,000 male. So maybe in that case you are getting a figure in different cities, say it is now you can say 938, 942, and in few Indian cities you have even more than 1,000. So that means there the female population is more than male population. But this is the overall population characteristics and it's the entire population. Now if you want to capture the sample which is also equivalent to that percentage, so probably in that case this kind of randomness will be very difficult to capture, and in such cases like this kind of true randomness or maybe this systematic sampling will not give you the desired result. But at the same time, like if you know that your work is on certain kind of walking trip measurement or something where you expect that okay, it is already something where the male population they are making more trips towards the work trip. So in such cases, like definitely you will get higher percentage of male. So you have to justify it that why it is more. It's not something wrong that you have done, but if it is something like is a very contextual and then there is certain reason or rationale behind getting that number of higher percentage of male than female, that is something that you need to justify. I give you another example. Say if you want to capture the driving behavior, okay, how people drive their car, and also it is on some kind of national highway. So in such cases it is observed, even there are certain published document, that for highway most of the cases the drivers they are male. So it is nothing to discriminate the male and female with this example, but only intention that it is observed that most of the cases for the highway and all, the drivers who are driving the car, even the personal car, most of the cases it is male population. So if in that case if you get a higher number, say as high as 80% male and 20% female, so that is not similar to the characteristics of overall male population distribution in that particular region, or who are making exact population data. So the intention here to capture the driver's behavior. So my target population is on driver, and if there I will find that okay, overall data says it is 80-20, so my sample should also represent around that. It should not be just the other way around, that you will find through your survey and you only surveyed the female drivers and say that okay, in my sample it is something like 70 to 80% female drivers, and then uh, remaining are the male drivers who are driving their own car on national highway. So that means there is some sort of understanding that we should have behind our justification towards the sample that we are selecting, and then for the sampling as well. So here the systematic sampling is how it is different from the simple one. Simple one is having a randomness, and where you cannot get any pattern, but still in this case also the proper selection, if we have any other objective to select certain number of male or female, will not be assured. For systematic sampling also it is not assured. Okay, now coming to the next one, all these constraint that I have mentioned just a few minutes ago, that if I have certain target that I have to keep 3 male, 2 female, so in such cases what we can do, we can go for stratified sampling. So that means the entire population we just divide it. Okay, I'll go for intention that male and female. So if it is say 60% and it is 40%, or it is 50%, it is 50%, fine. This particular population, what we have, if we make a count of total male population in this, so 1, then I just give number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So altogether in the set of 20 we have 12 male and then remaining 8 female, fine. So we divide this, so we have 12 male and we have 8 female. In that particular case my objective is to select 3 male and 2 female. So in this particular case 3 male should be selected out of 12 male population and then 2 female respondent out of 8. So in both the cases, like we first stratified the entire population, and now this 3 male out of 12 can be selected in many ways. It can be something like the first 3 I can get, so this is done, or else I can take this, I can take this, I can take this. So this is something where we will apply the random sampling, that I first segregate, I just stratify that particular total population and then I apply the simple random sampling. So for that I am not sure that out of 12 which 3 male respondent will come finally. So that selection is random, but I am giving a stratification right at the beginning, that okay, it is not that I randomly pick up from population, I pick up from the male population. I pick up 2 female out of female population, where in this case it is 8. So this way you will make assured that okay, whatever the required sample for your study, so you can get it very easily through this. Now there are other few possibility that it is only male female is one subset, but if you want to do this particular sampling based on age, so this is something again you can make more stratification. You can capture probably the like you can say the age group below 18, or maybe the school going trip, then you can say the middle age or the youth and middle age and then the elderly population. But the difficulty of doing this kind of stratification for age or income is not very easy. Why? Male female apparently you can identify very easily, you can tap without asking this question, but for age and all, always will have a judgment. So if somebody is, say for example, he is maintaining his maintaining well, and then probably you cannot judge whether like he belongs to 40 or maybe 45. So there will be no clear distinction. So in such cases it is difficult, but for there is a control. For data collection, you keep a track on, asking this question what age group he belongs to and other thing, then definitely you can make a hold on something. Once you reach to a number that you required for your sample, then maybe you can focus on something you suspect the age which is above 60 or something. So that way also we can do the stratification. So the main purpose of stratification is to make assured that the required sample of the characteristics that you require for your study is maintained, right? Unlike previous two, where it is giving some sort of randomness, whether it is simple random, truly random, or maybe a systematic random. But in this case, it is the stratified random sampling. Also, you say that we first make the stratification and then do the sampling. So here is the case also we have to only select. So there are many ways to select it, and this way we can do our stratified sample. Now for the example, if you want to do a sample survey to understand the socioeconomic perspective, socioeconomic status and the overall development of that zone perspective from different user group. So in that case you have to give a economic stratification or income wise stratification, that okay, this belongs to the high income who are having some income over this amount, or maybe something who are having income below that particular level, and then you take the representative sample to represent the population that is on the low income group or high income group. Altogether it will be a total population of a study area, but within which there are certain kind of stratification. So hope this is clear to you. With that we move to the next one. So in this case we divide the population into cluster and randomly select the entire cluster for inclusion. So in such case it is not like the previous one where we just stratify particularly making a target that male female and then we select it. Here we are dividing into cluster. So this cluster is something you can divide for you can say make it simple. Like in this case if you make a study area like something like having a mix of different income group or different socioeconomic or cultural difference, and then you just take any of the cluster which represent the best the population. It is difficult, but though it is something to help you out to do the representative survey, where you will find some sort of uh, huge population, and then for that probably you will find that okay, there is some sort of pattern in their homogeneity in their income, in their particular overall cultural value, or maybe their some of the activities, then the cluster sampling can also help you out. But in this case, after making the successful clustering, the selection of the cluster which one to be picked up, that will be random in nature. So that is something we have discussed this in something similar to the quota sampling, but in this case it is something which is little different, because here the randomness we select that particular cluster. So here also we divide the population into different cluster and we pick it up. But in the cluster sampling also the specific requirement may not be fulfilled, because this is very tough. Here we can make a like depending on the city size, the population size, it will differ, but maybe through this capturing a specific group specific identification of the respondent is difficult. So this is all about the 4 types commonly used type of probabilistic sampling. Now come to the characteristics. It overcomes the challenges of non-probabilistic sampling. The biasness is off. So I cannot say that okay, I know this person, that I understand that this person can give me the best result, or it's actually representing the uh, entire population, so that biasness is gone, as because it is random, and if it is with the statistically determined sample that will pick up out of that, so that is much more acceptable. Samples are selected randomly to provide equal chances to everyone, so that is something is very important. It's not very much deliberate sampling, that okay, I just ask the topper in the class and ask the question, or I just ask the average performance wise, like some student I'll ask, and then probably that will not work. Risk of losing the population representativeness, also in this case we cannot say it is totally bias free, because even if when you go for such kind of cluster sampling or stratification, maybe we can miss out some of the important segment of the population. So this risk is always there. The data might not indicate the actual variation in the population. So again, this is something very pertinent to the clustering technique, and then for that definitely you should capture it. So in such cases, like if that your study requirement fits very well, so stratified random sampling may be little bit on that safer side, because there the purpose of your study, and accordingly you just make sure that the samples that are collected through this is representative. And the method of this simple random sampling or random sampling is little bit expensive and time consuming, because in that case, if you say the first example of random sampling, where you have to select the respondent in the number that you generated. So that means if it is something that even if you get a person who is coming, say the metro passenger survey, again I am referring that. So even you see the second person is coming towards you and there is some willingness. So in such cases, if you want to follow the randomness, you have to skip that. So it will take longer time and also expensive. Normally this kind of sampling is done where the population is huge and you need a huge amount of information and the sample size is more. For other size like the non-probabilistic one or judgment one, where the small sample will work for you, and based on your convenience, based on your judgment on the quality and ability of the respondent, you can select that. So that was the advantage of non-probabilistic thing, but the biasness was there. Here we can overcome the biasness, but you have still certain kind of risk associated with it. So selection of probabilistic sampling, the type of sampling will depend on your data requirement. So you have to understand that it is not that I can apply everything and try to see which one is the best. You have to logically think that what is your purpose. If you want to target the overall characteristics where the sufficient amount of sample which is representing the population will be work for you. If you want specific characteristic to add like male, female or income level or the age group or educational level, so probably you have to think for some kind of stratification first and then go for random sampling. So in order to summarize this particular lecture, we understood the probabilistic sampling, why it is called probabilistic, because it is random in nature and there is equal chance or probability to get selected. Anyone can be selected as respondent out of population. And types of sampling, here we have discussed about simple random sampling, systematic random sampling, stratified random sampling, and then the cluster sampling as well. And also we discussed some of the advantages and disadvantage like cost and time for this particular probabilistic sampling, which is definitely to be looked into. Depending on your availability of resources, the purpose, you should pick up whether it should be probabilistic and non-probabilistic. So here we end these two type of sampling technique mostly used. You may come across different other sampling technique which is look similar to this, but this is not being discussed, you will not find it here. So if you have such kind of questions, so write to me through the forum, and we'll get back to you with the answers. I'll be happy to answer those questions and interact with you more in that forum as well. So with that, these are the again few books that you can refer. With that, we end that sampling part. Now, in our next lecture, we'll be discussing on the source of data. So, as we have discussed in the very beginning of the entire research process, the data type, like data sources, they are also equally important. One is the data type, other is the source of data. That whether it is primary data that you require or it is secondary data that you require. So, we'll discuss in detail in this particular lecture. So, till then, thank you once again, and please go through all these lectures. If you have any doubt, write me in the forum. Thank you for joining.